Hi, my name is Ethan, an amateur astrophotographer. I take images of deep sky objects, nebulae, star clusters, galaxies. This is a story about one of my unexpected discovery. It begins with an image I took last year of a galaxy called Messier 81. I live in a city with heavy light pollution. A normal day for me looks like this. Night sky is so bright, very few stars are visible to me, let alone all the deep sky objects. But astrophotography has a merit. I don't need to see my target. If I take many images and stack them together, most light pollution and noise could be removed. And this time, I took it to a little bit of extreme. For this project, I've taken 14,000 monochrome images, around 120 hours exposure for this single image. It took my PC a whole week to process all the 500 gigabytes of data. But the result pays off. First, I want to show you where M81 is. I took this time-lapse video in a remote dark site. My telescope was pointing at something else, but M81 happened to be in the frame. We are looking at North. We have the North Star Polaris, the Big Dipper, M81 is just about 10 degrees away from the tip star of the Big Dipper. This is my image of M81 galaxy group. M81 is a grand design spiral galaxy, about 12 million light-years away, a neighbor of Milky Way galaxy. M82 is a starburst galaxy. With its side towards us, its shape gave its nickname, Cigar Galaxy. Beside the galaxies, I also captured the faint white cloud around them. Those are integrated flux nebulae. Normally, you can only capture them in a very dark environment. However, all these are not what this video is about. In 1995, the Hubble Space Telescope took a long exposure, 100 hours to a seemingly empty patch of sky, which is here, not far away from M81. It revealed 4,000 galaxies crammed in an area smaller than a tenth of the moon. This is the famous Hubble Deep Field. Now, with 120 hours of integration time, I think I can call this my own deep field. Look closer. There are galaxies everywhere. Those galaxies are hundreds of millions of light years away. But we are still going deeper.
The study of thousands of these so-called spiral nebulae has proved that they are actually vast island universes, billions of miles in diameter and similar to our own galaxy. Each of these distant blurred dots is a spiral nebula made up of millions of stars like our own universe, but they are so far away that their light must travel over 100 million years before reaching the Earth.
By the 1930s, we had discovered that our Milky Way galaxy was not the only one. we were able to observe galaxies as far as tens of millions of light years away, but telescopes back then could only take us so far. In 1963, astronomer Martin Schmidt changed all that. By analyzing the spectrum, he realized the one point of light we previously thought was a star in our own galaxy was actually something else entirely. It's an object 2.4 billion light years away with incredible luminosity. We call them quasars, quasi-stellar objects. It's a supermassive black hole in the center of a galaxy, surrounded by a gaseous accretion disk. The disk spins so fast, some part of them can reach speed of light. Friction heats up the material in the accretion disk, releasing enormous energy across the whole electromagnetic spectrum, making the quasar shine thousands of times brighter than an entire galaxy. To put into perspective, every minute, the most powerful nuclear power plant on Earth converts 5 milligrams of uranium to energy, the weight of a grain of sand. In the same time, a typical quasar converts 100 Earth masses. The incredible energy output makes them visible across the entire universe. Martin Schmidt was on the cover of Time magazine and compared to Galileo. Sadly, he passed away last year. The discovery of quasars opened up a new window to the cosmos, revealing a much larger and older universe than I ever imagined. Distance between us is so vast, it also gave us a chance to look back in time, to study the universe at its younger stages. Thanks to the long integration time, the most faint object in my image reached apparent magnitude 22, dimmer than a candle, 10 miles away. With the data from the recent Sloan Digital Sky Survey, now there are more than 1 million quasars recorded in the catalog. Using the software, I'm able to apply this database to my image, and this is the result. It marked hundreds of quasars. Look closely and understand why we call them quasars. They look just like stars. The number is the redshift value of the quasar. The bigger the number, the farther and older they are. This is the relation between redshift value Z and the age and distance of the quasars. If you look closely, you may find most of the quasars in this image have the redshift between 1 and 2. This is evidence that quasars were more common in the early universe. Most quasars exist between 7 to 10 billion years ago, when the supermassive black hole consumed all the gas and dust near it. The energy production ends, leaving behind a normal, more peaceful galaxy. Some suggest that the supermassive black hole of our own Milky Way galaxy has gone through the same process. Maybe in 5 billion years, the Andromeda Galaxy and Milky Way collide. The supermassive black hole will be fed and ignited again. Among all the quasars, one number caught my eye. This quasar has a redshift value of 4.1. It means light from this quasar has traveled in space for 12.1 billion years, crossing a distance of 21 billion light years before reaching my little telescope. Our universe is only 13.7 billion years old, so this light was emitted when the universe was only 10% of its current age. It was the time of Genesis. Galaxies were just starting to form. Our solar system wouldn't exist until 7.5 billion years later. To give some context, the first quasar Schmidt found was 2.5 billion years old. The oldest quasar we know now is 13 billion years old, and the most distant object so far is a galaxy found by JWST last year, 13.6 billion years old. After a little research, I found this quasar is not a normal one. This small dot is 20 trillion times brighter than our Sun, and the supermassive black hole which powers it had mass of a 6.3 billion suns. This quasar is in the top 3% of all quasars, a giant among giants. Numbers this big have lost their meaning. I cannot imagine what 20 trillion suns look like, or how far 21 billion light years really are. I can't even think of an analogy. The scale of the universe is simply not in our language. But still, I learned something. When I started this hobby, all I thought about was taking pretty pictures. But now I know astrophotography is much more. Maybe there's a story behind the most insignificant point of light, a story of human curiosity and hundreds of years of discovery. Astrophotography is about learning things that I never thought about, and sharing them with others who might feel the same wonder. I often get this question when someone sees my telescope. How far can it see? Now my answer is the edge of the universe.